Well, it's time to look at Chapter 2, Insightful Inquiry, and I think this is quite a fun chapter. I would divide it into these three sections. So in the first part, he starts with the story of Newton, and he talks about the quest, if you like, for understanding the scientific method, and there's some general points about inquiry there. The second section is him talking about the intelligibility of the world, as in the fact that the world can be understood by us, and he thinks this is hugely significant, a non-trivial fact, he says. And then this leads him into a discussion of the anthropic principle, including his own sort of version of this, and he talks a lot about cosmic knobs, which sometimes gets a bit of a giggle. So let's make a bit of a start. One of the most powerful human motivations is the need we feel to make sense of our experience, to gain a coherent and satisfying understanding of the world in which we live. It is a quest that unites science and theology in comradely concern, for they are both attempting to explore aspects of the way things are. I'm just going to pause here because that's another classic soundbite from him. Do take particular note of his metaphors. So, as you remember, he's used the idea of theology and science having a fraternal relationship, and we talked about the idea of them being brothers and therefore of essentially the same, from the same sort of root, and that root is the desire to understand and know and interpret the world. Then he uses the word twin disciplines. This is all, I think, actually in the introduction. And now he's got comradely concern. And just think about that metaphor. A comrade is someone who shares something with you, that you're sort of in it together. You're sort of, brothers in arms, as it were. Of course, sisters in arms. And I don't think he's talking about communism, but there is a sense in which there is a shared practice. So you should be able to remember the comradely concern. It's, again, nicely alliterative. And I think we should always appreciate the choice of language that Polkinghorne uses here. He's a clever writer, and we can put on our sort of English literature hats for some of it to think about what he's actually saying, through how he's saying it, through the metaphors, sometimes similes, analogies, and just choice of language. So, with that in mind, let's now continue. That quest will not succeed without a commitment to a belief and an openness to its correction. The flux of experience has to be interrogated from a point of view that enables us to select the significant in terms of a tentative order. Many men had seen apples fall from trees. Only to a man concerned with the possibility of a general law of gravitational attraction did it occur to ask if that falling might be a manifestation of the same force that kept the moon in its orbit around the earth. Yet Newton's insight had to be tested against further investigation of the world. The inaccurate value then believed for the radius of the earth did not at first permit a perfect reconciliation of the moon's motion with the behaviour of bodies falling at the earth's surface, if both were to be described by an inverse square law of gravity. Even when that discrepancy was put right, a further difficulty remained, this time in terms of an insufficient understanding of the implication of the idea being developed. Only when Newton was certain that he was right to assume that a spherical body like the Earth would behave gravitationally as if all its mass were concentrated at its centre, was he able to publish his great theory. By that time, he had come to a realisation of how truly universal a phenomenon gravity was. To us, with all the illumination that hindsight brings, it seems strange that he hesitated for a while to apply the gravitational theory, so successful in describing the motions of the planets, also to give an understanding of the way comets behaved in their encounter with the solar system. In that little story, we have 4 elements which characterise all engagement with the search for understanding. Firstly, the adoption of a belief. Secondly, its interaction with experience. Thirdly, its fuller conceptual exploration. And fourthly, its generalization to the widest possible range of experience. So let's just pause there and unpack that page for a minute. Now, again, you don't need to worry about the techno-babble, as I like to call it, of the science, if that befuddles you. Really, the reason that he relates the story of Newton is in this last bit that we just read. He's just using it as a prime example, a prototype or an archetype, perhaps, of what he calls the engagement in the search for understanding. So firstly, he adopts a belief, and this belief is that there is something that keeps us grounded, that makes apples fall. And I think the first point is, I've highlighted this, but many men had seen apples fall from trees. This is not something new. Newton was, of course, very clever, and this whole thing with the apple falling from the tree on his head is somewhat apocryphal. Maybe it didn't actually happen, but certainly he would have, almost certainly he would have witnessed apples fall. He, I'm sure, witnessed many things fall to the ground. But it's only the idea of, is there something that makes all things fall to the ground? Let me explore that according to Polkinghorne, is the search for understanding in terms of the scientific method. So we have an adoption of belief, and then it interacts with experience. Now, you might say, is this actually the other way round? Are 1 and 2 swapped? Do we not see something occurring and then we adopt a belief? I think he's assuming that there's been some experience, then we adopt a belief about that general experience, and then we see how that belief interacts with common experience. And maybe it would be better if he'd swap around 1 or 2. Let's not quibble about that. When he talks about the further conceptual exploration, that is in the story how he is... how Newton, he says, comes to describe this the inverse square law of gravity. So he's testing out basically theoretical physics to test whether his theory works. That's the fuller conceptual exploration, and its generalization to the widest possible range of experience. So once we've got this theory, how does that then fit with our experience as far as we can possibly put it? And we can't put it to extremes. Newton, when he was writing, obviously couldn't take it to the moon because no rocket had yet been built that could get him there. Now we can and have, unless you're one of those people that think we haven't been to the moon, but let's just say that we have, and there are currently missions to Mars and so forth. So we can look at how gravity works as a force on other planets or other planetary bodies within our solar system. And that's the range of our experience to date. And then, of course, we're using all kinds of maths and stuff to look at gravity more distantly than we can actually travel as well. So that is what he's talking about, the boundaries of our experience, using these theories that we've developed from the interaction with experience and the testing. So gravity seems fairly, I suppose, uncontroversial law of physics to talk about, and I think it's therefore a good one for him to discuss there. He's going to now take that point and just, run with it a bit further. So let's read on. It is the search for understanding that inspires the scientist to undertake the prosecution of his research. The occasional moment of resulting illumination is the payoff that makes worthwhile all the weary labour and frustration inevitably involved in that endeavour. However much the positivists may tell him that he is simply seeking the harmonious reconciliation of sense experience, or the instrumentalists assure him that it is the power to manipulate phenomena that should be sufficient reward, he knows they are only tendering him an impoverished and inadequate account of his doings. They offer him a philosophical stone, while it is the bread of comprehending the pattern and structure of the physical world that he is seeking. I'm just going to pause there because when he's talking about positivists, remember that means that logical positivists, people such as A.J. Ayer, Moritz Schlick, to early Wittgenstein, and these people that would say that only things that can be tested, can be verified in principle, have any sort of merit. The bread and the stone is, of course, an allusion to that saying of Christ when he says, which of you would give his son a stone when he asks for bread, if you who are evil know how to give good things, will not your heavenly Father give better things to his children? So again, there's quite a lot of Polkinghorne that you kind of miss the richness of his, not just his argument, but the richness of how he presents his argument through quite a lot of powerful allusions, both religious and philosophical, and of course scientific. Now, incidentally, this next clause was written or added to the 2006 edition, so added in this edition of the text, because obviously he was writing a bit earlier in the original edition. I've looked at the a couple of early editions, and to be honest, I don't think very much has changed at all. This is the edition that the exam board, I think, recommends, but it doesn't really matter. You're not going to see any major differences, but here we go. Possibly this science is out of date. I don't know, but you can look at that. It might well become out of date, in the next few years. But nevertheless, as I write, he says, in 1987, several groups of physicists are investigating certain rare events taking place in large experimental arrays deep underground, with many thousands of feet of rock above them to shield the experiments from the unwanted intervention of stray cosmic rays. I mean, basically, the big hadron colliders, right? Is their aim to tell a pretty story about the occasional scintillations they observe, or to gain some manipulative ability in relation to the slabs of material at the bottom of a deep gold mine? Of course not. They are hoping to determine whether, as some physicists have suggested, the proton is not a completely stable particle, but very, very occasionally decays into lighter particles. Their results will add to our knowledge of what is. This is essentially an epistemological point, right? He is saying, essentially, that physics is giving us some understanding of some reality of things that exist. It's not just purely abstract. And that potential knowledge gains a significance and interest, justifying the expenditure of money and effort involved, because such an instability, if detected, would encourage the belief, now held by many, that potential knowledge gains a significance and interest, justifying the expenditure of money and effort involved, because such an instability, if detected, would encourage the belief, now held by many, that there is a grand unified theory, GUT for short, that unites three of the four fundamental forces of nature. GUTs offer the possibility of a deeper and more general understanding of fundamental physics than we have achieved hitherto. And there's that idea of deeper as well, and more general understanding. He on and on and on, hashing this phrase about the depths of understanding. So do take note of it when he uses this, and compare how he understands the deeper understanding in physics and the deeper understanding in theology as well. A Theory of Everything, if that helps you think of the film with Eddie Redmayne playing Professor Hawking. As an aside, it would be very nice if people expended a lot of money and effort into philosophy. Maybe a lot of effort, but not a lot of money, probably because you cannot sell its products. But I digress. Let's continue then. Whatever the eventual fate of that particular investigation, this century, he's talking of course about the 20th century at the moment, has already seen an impressive advance in our understanding of the structure of matter. At its beginning, there were still some physicists of repute who were sceptical about the actual existence of atoms. By this time I became a research assistant in 1952, atoms were already large systems from the point of view of elementary particle physics. And it was the protons and neutrons forming the constituents of atomic nuclei that were the objects of intense study. During my professional life, a further revolution has taken place in our understanding. Protons and neutrons themselves are now considered composite, with the quarks and gluons their constituents. There is rather a lot of different quarks, and people are beginning to wonder if there's something that they themselves are made of. I'm just going to very briefly pause here to show you a little diagram, not my own. I got it from livescience.com, and do follow the link and have a look at that page yourself. But as you know, hopefully from GCSE physics, you've got here the atom. The atom is a word that is supposed to denote something that is very simple, and like the smallest, simplest substance. But of course, that was now known not to be the case. And so within the atom, you have the nucleus, and it's made up of electrons and protons, as you know. And then, but within that, you have these gluons and quarks, and so forth. And then there's a postulation about strings and things. So look, don't worry too much about, again, the mechanics of the physics of it. What I would recommend that you do in this passage is just make a reference to Leibniz and his monadology. If you remember, Leibniz defines a monad as the simplest substance, something that cannot be broken down into anything simpler. An atom, but not actually an atom. Leibniz obviously writing several hundred years ago, and his point isn't that he thinks that he knows about them, but if you remember, he says there have to be monads if there are complex structures. So I'm just going to again pause the text just to make sure we've remembered this point, because I think it is quite important. So Leibniz in the monadology is arguing that if there are complex substances, they have to be comprised of simpler substances. So if you take a pile of books, this complex pile of books is made up of books. So that can be broken down. Now let's take this book, Don'ts for Husbands. Probably some advice that I should actually take. Don't judge your wife's motives. She may do a thing from a motive that would never occur to you and be perfectly justified in her action. Well, thanks. It is going to be broken down into pages, isn't it? Right? So this now seemingly simple substance, it's simple because it's simpler than the pile of books, can be now broken into simpler substances. Still the pages that comprise the book. Now you take out one of those pages Obviously, you have a sheet of paper, and that sheet of paper itself can be broken down into yet more simple things. And the arrangement, how complex substances come to be, is by the adding together of simple substances. And then his whole point is that if we know that there are complex substances and they're made of simpler substances, therefore there must be simple substances must exist. And then if you go down and down and down, there must be something that's completely simple that can't be broken down into anything else. Otherwise there wouldn't be any complex substances, even if we don't know exactly what that simple substance is. Now here's the thing, we said that in order for the pile of books to make, that doesn't happen instantaneously, that happens by bringing in things that are sort of less complex but still complex into some arrangement. But if you have something that can't be broken down into anything further and can only be instantaneously destroyed and instantaneously created, says Leibniz, and then of course he goes on to try and argue that the only thing that would have power to bring into existence these instantaneous monads would be God, who himself is of course simple. So there's a nice little link to cosmological arguments there. But all I think Polkinghorne is saying is, look, there's a limit to what we know. In his own lifetime, in his own professional lifetime, the science has changed so much, and it's perfectly possible. In fact, it's quite probable that given another 50 years at the rate at which our understanding is advancing, the assumptions that we had about the composition of subatomic particles will also change. And so we have, I guess, in conclusion, this sort of point, thus, the relentless search for an understanding of the structure of matter continues. It is not a done story. Okay. It is one's scientific instinct to seek for the fullest possible understanding of what's going on. I've already said that. Within the sphere of scientifically posable questions, we have no reason to think that such a pursuit will not yield scientifically statable answers. Science achieves its success by restricting itself to a certain impersonal mode of inquiry. Its power lies in its ability to interrogate and manipulate the phenomena. Even observational sciences such as cosmology or evolutionary biology depend heavily upon the results of experimental sciences such as physics or genetics for their capacity to interpret the data. In the intellectual world, nothing comes from nothing. Every discipline has its foundational assumptions, providing the platform upon which it erects its edifice of understanding. Science assumes the intelligibility of the world, that it is open to our rational inquiry. Now let's pause there. I like this idea of the edifice of our understanding building up on things, and of course we've got to consider the fundamental assumption of science. But just pause and reflect upon the axioms of other academic disciplines. So, what, for example, does music assume? Well, it assumes that there are sounds. It assumes the harmonic series. What does geography assume? Well, it assumes that there's an earth. What does history assume? It assumes that events happened in the past and that we can kind of know about them to an extent, and that we might be able to draw some lessons from the past. And presumably it also makes some assumptions about the way in which humans interact and behave. Politics also assumes that people are social and construct societies in various different ways. English literature assumes that authors have some intention behind their writing, as we've been looking at as well. So that every academic discipline has these fundamental assumptions, and it's fine that we all kind of ignore them, but maybe we should sometimes just pause and recognise and sometimes have to interrogate them. So what is science assuming? Here, the intelligibility of the world. He says that it is open to our rational inquiry. So it's possible for us as human beings to get to grips and to understand the world. And without that, if scientists didn't assume that, then they wouldn't be able to do any science at all, would they? So go back to the story of Newton at the beginning of the chapter. It's only because he assumes that the world behaves rationally and we can investigate it that it's worth him getting out from under the apple tree saying, okay, well, why did the apple fall on my head? So it then seeks to explain the discerned regularities of the world in terms of the outworking of the basic laws that govern the phenomena. These laws are science's given, in the sense that their form, for instance, an inverse square law of gravitation, and the constants of nature specifying the strengths and balances within them, such as the gravitational constant fixing the magnitude of the gravitational force between two given masses, are read out from nature. Now, that idea of reading out from something should remind you of a bit of exegesis. So compare that to exegesis, which is reading out of a text, and here he's reading out from nature. These provide the data in terms of which science then attempts to answer the question, how, posed in relation to the processes of the world. Of course, the modern form of the answer to that question is much subtler than the rigidly mechanical view of the 19th century. I think this is an important section coming up. So do make some notes of this idea of the mechanical view of the 19th century. He's going to refer back to Paley. You remember that in order for there to be a divine clockmaker, it suggests, it presupposes that there is a sort of a clock in the first place, and so this sort of more mechanical worldview. So we have here the clear and determinate world of Newton and Maxwell. Remember, he cited Maxwell on the very first page of the introduction when Clerk Maxwell laid bare the essentials of magnetism. And he says that this determinate world had dissolved at its constituent roots into the cloudy and fitful world of quantum theory. And I like this idea of the cloudy thing. There's a book called The Cloud of Unknowing, and it's a sort of quite old Christian text, which it talks about the sort of uncertainty of being able to speak meaningfully about God, and that sort of idea of the mysticism and the via negativa, or the way of negation, or apophatic theology, saying what things aren't. So again, a nice little link there between the two disciplines. All the same, the world remains a cosmos whose orderly pattern we can study and admire. Two of the founders of quantum theory were Dirac and Schrödinger, famous of course for his cat. Dirac once spoke of this similarity in outlook, saying, "It was a sort of act of faith with us that any equations which describe fundamental laws of nature must have great mathematical beauty in them. It was a very profitable religion to hold and can be considered as the basis of much of our success." It's at this point that I would rule off our first section, somewhat perhaps arbitrarily, and we'll begin section 2. And it might interest you to know that this particular section was the extract in the 2014 exam. So look up that past paper, and you'll see why. I do think they tend to pick, things that are in a way a little bit obvious. So, those imbued with a thirst for understanding will not find that science alone will quench it. Not only is the teeming, chaotic, fertile world of personal experience, which the cold, clear lunar landscape of science populated by the metastable replicating systems with no people in it so signally fails to describe, who thinks of himself as a collection of quarks gluons and electrons, there is also the founding faith that science depends upon, the data which themselves call irresistibly for deeper explanation. It's that phrase yet again, deeper understanding, deeper explanation. That the world is intelligible is surely a non-trivial fact about it. I told you that was coming up, so just make a note of that, highlight that little phrase. And the basic laws and circumstances of the universe exhibit a delicate balance that seems necessary if its processes are to involve such complex and interesting systems as you and me. It is surely inevitable to inquire whether these facts are capable of a more profound comprehension than simply the statement that they are the case. If you remember, David Hume sort of quips that the world might be essentially a brute fact. This is repeated by Bertrand Russell in his criticism of the cosmological argument in the radio debate with Cobblestone. The world, he says, just sort of exists. And Polkinghorne just says, look, we can't just ignore this. It's really quite significant. The world exists as something that we can understand, and the world exists as this environment that has evolved us to ask, why have we evolved? If that further understanding is to be had, it will be beyond the power of science to provide it. Let us consider these issues in a little more detail. We're so familiar with the fact that we can understand the world that most of the time we take it for granted. It is what makes science possible, yet it could have been otherwise. The universe might have been a disorderly chaos rather than an orderly cosmos, or it might have had a rationality that was inaccessible to us. I think that's quite important, these, if you like, counterfactuals. The idea of a counterfactual is that literally you are saying it could have been different, it could have been counter to the fact of how it actually is. We'll see that Hick uses several counterfactual hypotheses in his book on the problem of evil, talk about the world. Just to underscore those points he's saying, on the one hand, it could have been that the universe was disorderly, so a chaos, not a cosmos. Or it could have been, a chaos and an orderly, but not one that we can understand. It is, in fact, a cosmos, an order system that we can understand. And so that, he thinks, is incredibly significant. Suppose we were only able to conceive of things in geometrical terms, so the analytical rationality of the calculus would have been forever beyond our grasp. Then the circle would have seemed the perfect mode of explanation, and our search for an understanding of the solar system would have been condemned to an endless proliferation of epicycle upon epicycle, whether Ptolemaic or Copernican in character, and the beautiful simplicity of the inverse square law would have eternally eluded us. It has proved not so. Okay, just to remind you of the different models of the universe here, of course, you have on the left Copernicus's heliocentric model versus Ptolemy's geocentric model, as in helios, sun, from the Greek, and geo, obviously earth. So that's just what he's referring to there. Our minds have shown themselves to be apt and adequate for the solution of all the problems that the physical world presents to us. Even so grave a threat to intellectual coherence as must have seemed to be posed by the wave-particle duality of light was triumphantly overcome by the discovery of Dirac of quantum field theory, which achieved that unimaginable synthesis without taint of paradox. There is a congruence between our minds and the universe, between the rationality experienced within and the rationality observed without. So he has this idea of a mind-world congruence. I think that's quite important for him. World-mind congruence. This extends not only to the mathematical articulation of fundamental theory, but also to those tacit acts of judgment exercised with intuitive skill that are equally indispensable to the scientific endeavour. That is too profound a fact to yield to superficial discussion. Evolution can always be That is too profound a fact to yield to superficial discussion. Evolution can always facilely be invoked as the inexplicable explanation of what is found humanly to be the case. Think of Richard Dawkins, who is absolutely bad for this. By the way, he kind of picks up that point on page 107. He talks about Pangloss being made scientific, but I'll come to that later. However, it seems incredible to say that Einstein's ability to conceive of the general theory of relativity was just a spin-off from the struggle for survival. What survival value does such an ability possess? As Sherlock Holmes said of the practical value of abstract knowledge, "You say we go round the sun. If we went round the moon, it would not make a pennyworth of difference to me and my work." This is, by the way, from, I think, the first Sherlock Holmes story by Sir Arthur Conan Doyle, A Study in Scarlet, and Watson is amazed that Holmes doesn't seem to understand or have any knowledge of the geocentric model of the universe, and he explains this to Holmes, and then Holmes says, "Well, thanks very much, but I'm now going to immediately forget this piece of knowledge because my mind can only hold a certain amount of knowledge, and I've only got space for the stuff that's going to be useful, and that's not going to be useful to me." Now, that is really foolish, of course, because Holmes doesn't know when it will be useful. He doesn't know when he's going to have to impersonate, for example, a physicist when investigating the murder of some astrophysicist. And he's supposed to be a master of disguise, so he really ought to have known better. It's a rather foolish thing for Holmes to say. But never mind. Let's carry on. Certainly our powers of thought must be in such conformity with the everyday structure of the world that we are able to survive by making sense of our environment. But that does not begin to explain why highly abstract concepts of pure mathematics should fit perfectly with the patterns of subatomic world of quantum theory or the cosmic world of relativity, both of which are regimes whose understanding is of no practical consequence whatsoever for humankind's ability to have held its own in the evolutionary struggle. Nor does the fact that we are made of the same stuff, quarks, gluons, electrons, as the universe serve to explain how microcosmic man is capable of understanding the macrocosm of the world. Think of that wonderful speech, "What a piece of work is a man," in the middle of Hamlet. How noble in reason, etc. Some fairly desperate attempts have been made along these lines, nevertheless, showing how pressing is the need to find an explanation for the significant fact of intelligibility. Speaking of the highly dubious metaphor the universe is a computer executing a program specified by the laws of nature, Pagels goes on to say, "It is fun to explore the metaphor of the universe as a computer and examine what the relation of the cosmic computer is to any other computer. The soft machine inside our heads, the brain. The brain is certainly not a digital computer, nor is the universe, but it is an organ that transforms the information. But the brain is a far more complex computer than the macroscopic universe, and it is certainly possible for a complex computer to make a mathematical model of its simplest parts and the rules they obey. Not only does this go beyond what we presently understand about the mind and brain, but it also contains no explanatory power. It is simply the bare assertion of the fact that we can understand the world, dressed up in modish jargon. It is rather like the old-style doctors in Molière's parody ascribing the narcotic properties of opium to its possession of the dormitive faculty. This is another classic example where he's just alluding to some bit of literature that he hopes his readers understand. I hadn't come across this before, but you can nowadays Google things. So Molière, the French writer, actually that's his pseudonym, and you can look up the plot, but it's from a play called The Imaginary Invalid. And essentially the idea that he's saying here is that it's like a tautology, but it's sort of more circular and abstract. So it's an item that is explained essentially in terms of itself, but in a kind of more abstract language. So essentially, remember, you're saying nothing new with a tautology. So if the deep-seated congruence of the rationality present in our minds with the rationality present in the world is to find a true explanation, it must surely lie in some more profound reason, which is the ground of both. Such a reason would be provided by the rationality of the Creator. And that is coming to the end of section 2. So what is he saying? He's saying that the world is intelligible, and that is really significant. It's no good just saying, oh yeah, so we understand the world. We've got to explain why it is that we understand the world. And one thing that would seem to fit is that if the world obeys reason and rationality, that would seem to fit a rational creator. So you kind of see where this is going, and you could of course accuse him of just having another God of the gaps. But he's not saying, aha, therefore there must be, at least not yet. He's just saying, so it fits with this idea. We've got this big question, and this thing seems to fit in with it.